Alright guys, welcome to a screencast on lesson 9.4 where you have to factor out the greatest common factor. Before we really jump into this sheet, what's important to know is the fact that we have to know what a factor is. So, let's go ahead and jump right up to the top of this and we will define what a factor is. Factor is pretty simple. What it means is it's a number or numbers that multiply to make a number happen. And really it doesn't have to be just a number, it could also be a polynomial, which is what we'll be looking at in this case. So, if I asked you what multiplies to make the number 8, then you would tell me it would be the numbers 1 and 4. 1 and 8, sorry. And then the numbers 2 and 4. And then if we also looked at another number, for example, 24. The numbers that multiply to make 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay? Now from the factors you're going to have to find what's called the greatest common factor. And this is always going to be labeled as GCF. And notice today that GCF, greatest common factor, will get factored out of the problem. So it's basically going to get pulled to the outside of the problem, is what we're going to look at. So a GCF, or a greatest common factor, is basically the greatest one that they share. So out of this list and out of this list, we would say that the greatest common factor of 8 and 24 is the number 8. Okay? So if the case were 8 and 24, then we would pull the 8 out of each, which would leave 1 with 8, because that's the pairing with that number, and these ones just wouldn't matter then. And then here it would leave the 3 with the 24. It would leave that behind because that would be what is remaining once it's pulled out. So if we jump down to number 7, we need to find the factors that make up 10x. So how do we multiply to make 10x? Well, first off, you got to have the 1 and 10. Then after that, you'd have to have the 2 and the 5. And lastly, since that variable is being multiplied with the number, you have to add that variable on the end. So 1 times 10 times x would make 10x, or 2 times 5 times x would make 10x, and those are the factors of 10x. Notice 10y would be very much the same. It would be 1 and 10 and 2 and 5, and then the y would add on the end, because it would also multiply in there to make 10y. 1 times 10 times y, it makes 10y. 2 times 5 times y makes 10y. Okay? So what we need to do is we need to pick the greatest common one, the biggest one that they share, that we can pull to the outside. And right here, that's going to be the number 10 and the number 10 over here. Now notice the number that paired with 10 is 1, and the number that paired with this 10 is 1. So since we didn't pick 2 or 5, those are just not going to play a part of the problem. They're not going to play a role. They don't share any variables here, and so all we're going to pull to the outside is the 10, and then what's remaining is going to be left inside. Now to find that, I would very simply just divide by that greatest common factor. So 10x divided by 10, the 10's would cancel, which would leave x, minus 10 divided by 10 would cancel, and that would leave y. And that's the proper process in how to pull a common factor out front, and then the remainder is what is left in the parentheses. So let's jump over and try 17, since we got room to work that, and we can look at that. Factors of 6x cubed y. First off, I got to have 1 and 6. Then I got to have 2 and 3, because those are the two ways to multiply to make 6. After that, how do I multiply to make x cubed? That would be x times x times x. And lastly, I would have the y going on the end. Then I have 9y squared. That would be 1, 3, 3, 9, y times y. Because 1 times 9 times y makes 9y squared, and 3 times y makes 9y squared. So of this list of numbers and this list of numbers, what is the biggest one that they share? Well, the biggest one I notice is the 3. So if we use the 3, notice this 3 paired with that 3 to make 9, this 3 paired with 2 to multiply and make 6. Since we didn't use those don't matter. Since I didn't use these, those don't matter. Okay, this one had 3 x's to share, this one didn't have any x's. So those x's are going to be left behind. This one has 1 y to share, and this one has a y to share. So my greatest common factor here is going to be 3y. And that will go to the outside just as the 10 did before. And then I need the remaining left in the parentheses. So if I divide this by my greatest common factor of 3y, 6 divided by 3 is 2. Notice the 2 was the number that paired with the 3 to multiply to make that, so that's another big giveaway for us. Since there are 3 x's left, when we divided that, x to the third, we don't have any other x's to divide, so all 3 x's stayed in there. Now we pulled the y out. Y divided by y would be 1, so that would just leave 1 left, but when that multiplies with all that, it doesn't change anything, so it stays the same. So notice since this one went out and this one went out to the outside, it was no longer left in the inside. The only parts that were left were the parts that were remaining. The sign between the two was addition. The number that paired with 3 here, or if we want to show that by dividing, 9 divided by 3 is 3. Notice that was the number that was left. And then I have 1 y left because y squared divided by y, that would be 2 y's on top, 1 y on bottom. That would leave 1 y in the problem. So this would be the answer for 17. Okay, these problems up top are pretty easy. What you have to do here is when you have two separate parts set equal to 0, you take the first one, you set it equal to 0, and then you solve that equation by following the opposite operation rules. So if I subtracted 14 there, that would equal 0, which just leaves the x, and x would equal 0 minus 14 would be negative 14. There is one answer there. Then I would take the x minus 3 and I would set it equal to 0. Opposite operations would tell me to add, and x would equal positive 3. That's as good as that answer can get. Just to show you one more example, and by the way, when I say that's as good as this answer can get, that means there are two answers for one problem. And I can do the same thing down here. We'll work d plus 8 equals 0 there. Opposite operations tell me to subtract. This would cancel, leaving me with d to equal 0 minus 8, which is negative 8. There's one answer. Then I have d minus 1/2 equals 0. We would have to add 1/2, and that would cancel. Add 1/2 here, and d would equal 0 plus 1/2 would be 1/2. That's as good as that answer gets. So, once again, each problem is going to have two answers. Okay, now we need to jump down from this And remember, you can pause the screencast if you need to go back. You can go back, whatever you need to do. And what we're going to do is we're going to jump down on the worksheet, and we're going to do the ones that are a combination of both. And actually, we could take a look at 21 too, since that's a little different scenario. In 21, when you take the factors of the first, which are 1 and 8, 2 and 4, are 5 times, because there's 5 of them. And then the 20r to the fourth, which would be 1 and 20, 2 and 10, 4 and 5. Those are the ways to multiply to make 20. And then it'd be 4 r's. And then lastly, we'd have 12r squared, which would be 1 and 12, 2 and 6, 3 and 4. And this one's going to have 2 r's. Now in this one, we have to pull out the greatest common factor, and that is going to be the one that all 3 share this time, since there were 3 numbers. Well, first off, I know that this one has 2 r's to share. That one's got 4, that one's got 5. So that one has 2 to give, so does that, so does that. Numbers wise, it looks like the 8's not going to work. Wonder about the 4. It looks like 4, 4, and 4. So that must be the biggest number that they all share. So that would mean what's going to get factored out of here would be 4r squared. We pull that out of each, and if I divide that, that is going to give me my resulting answer. So the 4r squared comes out front, and what's remaining after the division is what's left. 8 divided by 4 is 2. R to the 5th divided by r squared, that's going to leave remainder of 3. Minus 20 divided by 4 is 5. R to the 4th divided by r to the 2nd is r squared. And then 12 divided by 4 is 3. Notice I just brought that same sign down that was there. And r squared divided by r squared leaves no r's remaining, so this is as good as our answer can get. Okay, let's jump down to 27, where we have to list the factors. That would be 1 and 5, w and w. This would be 1 times 5 and w. The greatest common one would be that they both share a 5, and they both share a w. That makes my GCF 5w. When that comes out front, I have to go with what's remaining inside. If I divide that by 5w, divide that by 5w, 5 divided by 5 is 1. W squared divided by w will just leave a w. And then the minus signs between 5 divided by 5 is 1, and w divided by w would just leave the number 1. That's as good as your answer can get. Since this is equal to 0, just like we did at the very start of the worksheet, we take the first part, equal to 0, opposite operations to solve. W equals 0, that's one answer. And then we set this equal to 0. We would add 1, and then divide 1, which when you divide 1 it doesn't change anything. So my answer is 0 plus 1, which is 1, and these are the two answers for that problem. Thanks for listening. That's the end of the recording.